7.5 Parallel lines are proportional parts. The triangle proportionality theorem and its converse. If a line parallel to one side of a triangle intersects the other two sides, then it divides them proportionally. If a line divides two sides of a triangle proportionally, then it's parallel to the remaining side. So here we're finding the segments. So we're saying that if these two sides are parallel, which we can see by these arrows here, then that means that these are proportional. So I can put x over 4, they are proportional to each other, and that's going to equal 10 over 5. And now I can solve by cross multiplying. So x times 5 and 4 times 10. And we're going to get that x is equal to 8. I can use the same logic in number 2. So 14 is the entire side. I could do this a few different ways. I can either say that, I can either find the entire side over here and say 15 plus 6 is going to be 21, which is probably the easier way to do this. Or I can come up with the length of this portion here by subtracting 14 minus y. All right, so I can do small over large, y over 14 is going to equal small 15 over 21. And now I can cross multiply. So y times 21 and 14 times 15. So we're going to get 210. So y is going to equal 10. We can determine if they're parallel by making sure that the sides are proportionate. So we can do 4 over 8, and we're going to get 1/2. And we want to make sure, is that the same as the other proportion, 6 over 12? Also 1/2. They're proportionate, so yes, these are going to be parallel. Same here. We can do 15 over 21. Both divisible by 3, so that's going to give me 5 over 7. And then we have 17 over 23, and that does not simplify, so these are not parallel. And that's because they're not proportional. We also have the mid-segment of a triangle, and the mid-segment of a triangle is the segment that connects the midpoints of two sides of the triangle, and it's parallel to the remaining side. So we have the midpoint of each of the sides of the triangle. This is parallel to the base, and that means if it's the midpoint that these two portions, here and here, are going to be congruent to each other, and that these two portions, here and here, are congruent to each other. So here we could say, if we are going to call this triangle ABC, and the other one, let's put an E and a D, we would say that the mid-segment here is going to be half of the base. It's half as big. Or we could say that the base is equal to 2 times the mid-segment if we went in reverse. Okay. This is considered our mid-segment here. Our base is this bottom portion. So let's find these values using these rules. Now I know I can use this rule because I'm seeing these tick marks here, and that makes this and this the midpoint, which means these are parallel, and that one is half as big as the other. So I have my mid-segment up here, I have my base down here. My mid-segment is equal to half of my base, or my base is equal to 2 times the mid-segment. Either equation, totally up to you. So my mid-segment here is 2p plus 7, and that's going to be equal to half of the base. The base is 16. All right, so 2p plus 7 is equal to 8. When I subtract, that's 2p is equal to 1, so I'm going to get p is equal to 1/2. Okay. I don't see the tick marks, but I do see 8 and 8, which means those are the same, and I see 11 and 11, which means those are the same. So I have my mid-segment, and I have my base. Again, I could use the same formula, or I could switch it up and use the other version of it. It's the same thing. My mid-segment is 14, and my base is 5q minus 9. So why don't we try the other one? So it's base equals 2 times the midsegment, and the midsegment is 14. All right, so that's going to give me 5q minus 9 is equal to 28. I'll add 9 to both sides, so I'm going to get 37. And then I'll divide by 5, so q is going to equal 7.4. All right, let's find the perimeter of this larger triangle. So the larger triangle is out here. In order to do that, we still need to find the base. So we have a midsegment, we have a base. We know that these are congruent just by looking at the values, 3 and 3, 4 and 4. So we can say that the base is equal to twice the midsegment, or that the midsegment is equal to half of the base. Does not make a difference. All right, so why don't we go with base is equal to, we don't know what the base is yet, is equal to 2 times the midsegment. The midsegment is 5, so that means the base is going to equal 10. And then if I want the perimeter of the larger triangle, I just have to add them up. So this side is 6, this side is 8. So the perimeter is 6 plus 8 plus 10. And that's going to give us 24. All right. We also have a theorem that says if there are 3 or more parallel lines that intersect 2 transversals, then they're going to divide the transversals proportionally. All right, so these are our parallel lines. Our transversals are here and here. We have point A, point B, point C, and we can call this D, E, and F for convenience. And then let's call this line L, line M, and line N. Okay, so if those 3 lines are parallel to each other, then we can say AB over BC is going to be equal to DE over EF. I could also say that AB over AC, the whole side, is equal to DE over DF, the whole side. Or lastly, I could say that BC, the bottom portion, over the whole side is equal to the bottom portion over the whole side. All of those things are going to be true. So let's take a look. All we've done is kind of turn it on its side. We have these points M, N, P, and R, S, T, and those 3 parallel. These are my transversals. Okay. We want to complete these proportions. So here we have MN over MP, which is the whole thing. And then we want to know what goes on top. RT is on the bottom. So we need the matching portion. That would be RS. Okay. For the next one, we have RS over ST. RS over ST. That's equal to MN over what? NP, the other matching side. And then lastly, ST over RT. So green over red is equal to green over red. And red here is MP. Okay. For this next one, it says in the figure below, A, B, and C are parallel. We want to find X, so we can set up a proportion here. We know that 9 and 15 will be proportionate, and we know that 12 and X will be proportionate. So we can do 9 over 15 is equal to 12 over X and cross multiply. 9 times X, 12 times 15. 12 times 15 is 180. So when I divide, I'm going to get X is equal to 20. All right. For the next one, again, we have those 3 parallel lines and the transversals, and we can set up a proportion, 5X over 3X, and that's going to equal 8X over 60. The only thing that makes this one a little bit messy is going to be the algebra, but since we have those X's here, we can simplify this fraction. So really, I can say this is 5/3 is equal to 8x over 60, and I can cross multiply. So 3 times 8x is 24x. 5 times 60 is 300. And when I divide, x is going to be 125. All right. For number 4, we want to determine the value of x so that BC is parallel to DF. Okay, so AB is x plus 5, BD is 12, AC is 3x plus 1, and CF is 15. All right, so we know that these are proportionate, so I can do x plus 5 over 12 is equal to 3x plus 1 over 15, and I can just cross multiply. So that's 15 times x plus 5, and that's equal to 12 times 3x plus 1. Distribute. And then combine. So we're going to move the 15x over to the right and get 21x. We'll subtract 12 from both sides and get 63. So that's going to give us that x is equal to 3. All right. And again, using similar logic, we're told that these are parallel. AC is 15, BD is 3x minus 2, CF is 3x plus 2, and AB is 12. Same concept. So 12 over 3x minus 2 is equal to 15 over 3x plus 2. And we'll cross multiply. So 12 times 3x plus 2 is equal to 15 times 3x minus 2. Distribute. I'll subtract 36x from both sides and get 9x. I'll add 30 to both sides and get 54. And then we'll divide by x to get 6.